Okay, so this says you have a mass m. This block has a mass m and this block has a charge capital Q. And there is electric field applied in this region. That is, the capital E is the electric field. And this block is kept at x equals to 0. And this block is further attached by a spring. And initially this spring is unstraight, that is the natural length. No expansion, no compression in this spring. And now this system is left from x equals to 0 with 0 velocity. Now you have to find what is the maximum stretching that will be possible in this spring. So what is the maximum stretching? What is the distance by which this block will move? So what will happen? So initially you see this block here. So let me make the diagram. So I can have something like this. So basically let me make again. So you have this block. So initially your block is here and this is your spring. Are you getting? Now what will happen after some time? So let me make 3 diagrams. So the next time this block will move, and so let us say it moves up to here. Now third diagram. So why I am making this 3 diagram, you can understand. So now third time you will have this spring and now you will here. So this is the 3 system. So this is basically x equals to 0. At this point of time you have x is equals to 0 and initial velocity that is given in the problem, that is also 0. Now you have a force that is acting in this direction, q into E. So it will accelerate in this direction, and basically there is a decelerating force also in this direction, but that decelerating force is a variable. So this decelerating force that is acting in this direction is k into x, and this is a variable, x changes. So this force keeps on increasing, and this force that is acting in this direction is always constant, and that force is basically q times E. So you see in this direction is a more force, so it will accelerate. So block will accelerate. After some time block will get maximum velocity. So let us say at this point x equals to x, this velocity block has a maximum velocity V max. And at this point of time acceleration of block will be 0. You see at this point of time what is the acceleration? Total force acting is QE, and a stretching force is almost 0 because there is no x. So Q is the maximum force that is acting. So QE divided by m, that is the acceleration of this block. At this point of time V is maximum and there is force that is acting in this direction and this direction, both are equal. So at this point of time I can say acceleration is 0. Are you getting? So acceleration is 0. But still it has some velocity. So this block will go some more further distance. Acceleration is 0, force is 0. So force external is 0, acceleration is 0, but this block will move further because this has a velocity, some velocity V maximum even. Because acceleration is 0, so dV by dt is 0. If dV by dt is 0, this means V should be maximum. This is the maximum minimum criteria. So at this point of time it has velocity, and that is the maximum velocity. So this block will move further some more distance. This is the only important point we have in this problem. So this means after some time it will reach up to x equals to x maximum, and when it reaches up to x equals to x maximum, at that point of time velocity will be 0, because if this is not maximum x, then it will go further. So velocity will have, so when you have maximum, then velocity has to be 0. This is mathematically written as dx by dt is 0, and that is basically velocity is 0. At that point of time you must have x equals to x maximum. Are you getting or not? So we can see this is the x maximum, velocity is 0. Now we have to find maximum x, and this can be applied easily using the energy conservation. You see at this point of time velocity is 0, at final point here you have velocity is again 0. So we can say energy conservation delta K, change in kinetic energy, equals to work done by all external forces. So if I apply this, so change in kinetic energy is 0, work done by Q into E, this is a constant force into distance. So distance is x maximum. Now this is the distance, and now work done by the spring force. So spring is acting in the opposite direction and movement is in this direction, and this is a variable. So you see this work done is half kx square. You can do this by integration also, and this is a negative. Are you getting or not? So if I apply energy conservation, I can calculate x maximum. So what is x maximum? So you see, x maximum will be, you can solve yourself. So this will come out to be, so I think this will come out to be k. So this x goes, so this is again x maximum, so this kx square is also x maximum. You can solve yourself. So this becomes 2qe, this divided by k, only thing. So this will have 2qe. So 2qe divided by k. So this is the maximum elongation you will have. So you can remember x max is equals to 2 times qe divided by k. So there is no mass term. So this is independent from mass. This is obvious. This should be only depend upon charge, because the forces that is acting in this direction, that is the forward direction, only depends upon charge. So this should be depend only upon charge. Let us say this is the part A of the question. So let us discuss part B. So what this part says, this says what is the equilibrium position of the block. This position, equilibrium. Equilibrium position is always decided by the force external is 0. So you see in this case, equilibrium position can be found by force external that is equals to 0. So you see, at this point let us say x is equals to x equilibrium. So if this is x equals to x equilibrium, I can say at this point of time force is acting on block. So this is the block. You can understand basically. This is easy, we can go fast. In this direction force acting is QE, and the opposite direction force acting is KX equilibrium. Are you getting? And now I can solve for equilibrium force, equilibrium x, so k into x equilibrium. This is equals to q into E. So x equilibrium is QE by k. You see, important point you have, this equilibrium x is half of the maximum x. This is the maximum x, this is equilibrium. So this is the half. This means from here to here, this distance, and from here to here distance is same. This is the important point. If you somehow use this expression for part number A to find out the maximum, you will get the wrong answer. Let us discuss part C. So that block motion is simple harmonic and determine its period. So now let us show the motion is simple harmonic and find out the time period. So this is slightly interesting part. So you see, what are the forces that is acting on block? So this is the block. On this block there is a force that is acting in this direction, QE, that is a constant force. In this direction there is a force acting, that is KX, and X is by this side. So now I can write equation. So QE minus KX is equals to mass into acceleration, so m, and acceleration is d2x by dt square. So this is my equation. Now, so this is a simple harmonic motion. It does not look like simple harmonic motion, but basically this is a simple harmonic motion. You can solve this one. So let us say QE minus KX. So what we will do is, I will change the origin. So let us say QE by m divided by m minus K by m into x is equals to this m goes, so we will have only d2x by dt square. So this is d2x by dt square. Now this is a minus x. So what we can do is, so let us use some z, new variable. Z is equals to, if you see QE by m minus K by m into x. So let us introduce a new variable. So I will have d2z by dt square. If you differentiate this two times, this is a constant, so this is 0. So minus k by m d2x by dt square. Are you getting? So this is d2x by dt square. I think all of you are understanding. Now if I plug this value, so this is this coefficient, this whole term is z. So this terms you have z. So this side is z. QE minus KE. So this is z. Is equals to d2x by dt square. So this is minus m by k. You can calculate yourself. So this term is equals to minus m by k d2z by dt square. Getting? In the next line I can write the same thing, something like this. So this is d2z by dt square is equals to minus k by m into x. Now this is z. Minus k by m into z. Are you getting or not? So time period, so omega is what? Omega is basically under root k by m. So time period is same. You see, even if you have simply no force QE, so this is independent from QE. So there is no term of Q and no term of E. So independent from Q as well as E both. So this means application of electric field does not change the time period, but it changes what it changes? It changes the mean position. You see, what is the mean position now this time? You see, this block will do SHM along, this is the mean position. This is the point where the total force is 0. Mean position is always guided by F external is 0. So mean position is x, this distance, that is QE by K. So this is basically E. So let me write here. So this is QE by K. So you see, you can also find mean position. You see, this is the equation. Z is equals to Q by M, K by M into X. So you see, mean position can also seen. So Z is equals to, this is a shifted mean position. So you see, this is equals to 0. So if you put Z is equals to 0, that will give you the mean position, because you see, in d2x by dt square we have x equals to 0. So if you put z equals to 0, that will give you the mean position. So QE by m minus k by m into x is equals to 0. So this is the mean position, and the same value you calculate at top also. So x equilibrium, that is the mean position, we have also calculated the same value QE by k on the top also. So this is the point mean position. So you check yourself, you get the same value. Are you getting or not? So you see, this is the same value here, QE by K. So I have to go slightly fast. So this is the same value, QE by K. Now last part says, repeat the part A, the coefficient of kinetic friction block and the surface is mu K. Now this time there is a friction between this surface, and that is the mu K. So what is the change? You will only change delta K is equals to work done by external forces. Now I have to add one more work. That is the work done by frictional force, and that is again negative, because frictional force will act in this direction, block is moving in this direction. So frictional force is mu into mg, so force acting is mu mg, and distance traveled, let us say x maximum. So I have to only make one correction here, I have to apply minus mu mgx. So let us say I can write in the next case, so this part D, you will have delta K is equals to work done by external forces. So you can do yourself. So this is 0 is equals to what are the work done by external forces? QE. This is the work into x maximum. So this is work done by the electric force minus half kx square. This is the work done by the spring, and friction will also do the negative work, minus mg times x max. So you calculate this, you basically cancel x, so you will have QE. These two forces are linear, friction force and your gravity force. Friction force and electric force are linear in nature. So this is Kx maximum. So if you solve from here, you will have x maximum is equals to QE minus mg. And this divided by this multiplied by 2 basically, and then you will have this divided by k. So you see, this time maximum will decrease, but how much? By 2 mg by k. You see, what is the initial maximum? You see, initial there is no friction, maximum is 2 QE by k. And now what is maximum this time? Now this time maximum is 2 QE by k minus 2 mg by k. So there is a decrease in maximum by how much? So decrease is by 2 mg by k. So this is the maximum decrease. Are you getting? So there is a decrease in maximum. So this is the important point. So one important point in this problem we have, that is the energy conservation we have to apply to find the maximum x. We cannot apply the mean position condition. We cannot apply the force is equals to 0 condition. And most of the people do the same thing. We'll discuss the next program.